Welcome to Digital Learning, Department of Collegiate Education. Myself, Dr.Lakshmi Janardhana, Assistant Professor, Department of Mathematics. In this video, I am going to present you BSc First Semester Mathematics. Let us learn about the chapter Differential Calculus under Calculus 1. Under this chapter, discussing the successive differentiation and nth derivative of some standard functions. The objectives of this session are to understand the definition of successive differentiation, to find the first, second, and third order derivatives, notations of successive differentiation, to apply it to derive nth derivative of some standard functions. By the end of this session, students will be able to understand the concepts of first, second, and third order derivatives, definitions of successive differentiation, nth derivative of some standard functions. Prerequisites: concept and the process of differentiation of a function y is equal to f of x of a single independent variable. The geometrical meaning of the derivative of a function at a point and its application. First order derivative. If the function y is equal to f of x is differentiable, then dy by dx exists and is called first derivative of y with respect to x. It is denoted by dy by dx is equal to f dash of x or y dash or y. Second order derivative. If dy by dx is equal to f dash of x is differentiable, then its derivative d by dx of dy by dx exists and is called second order derivative of the function y is equal to f of x. It is denoted by d square y by dx square is equal to f double dash of x or y double dash or y. Third order derivative. If d square y by dx square is equal to f double dash of x is differentiable, then d by dx of d square y by dx square exists and is called third order derivative of y is equal to f of x. It is denoted by d cube y by dx cube or f triple dash of x or y triple dash or y3. Successive differentiation. The process of differentiating the same function y is equal to f of x again and again is called successive differentiation. The derivatives dy by dx, d square y by dx square, d cube y by dx cube, so on, d power n y by dx power n are the successive differentials of the function y is equal to f of x. Related examples: find d square y by dx square if y is equal to x cube log x. Let y is equal to x cube log x differentiating with respect to x. Y differentiation dy by dx. To differentiate right hand side, we have to apply product rule. Differentiation of first function x cube becomes 3x square into log x plus first function into differentiation of second function log x is 1 by x. And if we simplify, we get dy by dx is equal to 3x square into log x plus x. Differentiating again with respect to x, d square y by dx square is equal to, again we have to apply product rule to differentiate right hand side. First term, x square differentiation is 2x, 2 3s are 6x log x plus first function into differentiation of second function log x is 1 by x plus x square differentiation is 2x. Then simplified term is d square y by dx square is equal to 5x plus 6x into log x. Find d square y by dx square if y is equal to log cos x. Let y is equal to log cos x differentiating with respect to x. Y differentiation dy by dx is equal to log cos x differentiation is 1 by cos x into, within that cos x differentiation is minus sin x. Then sin x by cos x is minus tan x. This is the first derivative. Dy by dx is equal to minus tan x. Differentiating again with respect to x, d square y by dx square is equal to tan x differentiation is secant square x, that is minus secant square x. If y is equal to a cos log x plus b sin log x, show that x square y2 plus x y1 plus y is equal to 0. Let y is equal to a cos x, a cos log x plus b sin log x. Differentiating with respect to x, then differentiation of y is y1, a into cos differentiation is minus sin log x into within that log x differentiation is 1 by x plus b into sin differentiation is cos log x into log x differentiation is 1 by x. Multiplying by x and both the sides, we get simplified term x y1 is equal to minus a sin log x plus b cos log x. Differentiating again with respect to x, to differentiate left hand side, again we have to apply product rule. X differentiation is 1 into second function plus first function into differentiation of y1 is y2 is equal to minus a sin differentiation is a cos log x into log x differentiation is 1 by x plus b into cos differentiation is minus into plus, again it gives minus only, b sin log x into log x differentiation is 1 by x. Again multiplying by x on both the sides, we get x square y2 plus x y1 is equal to minus of a cos log x plus b sin log x. This it represents the given equation y. Then minus y shift to left hand side, x square y2 plus x y1 plus y is equal to 0. This is our default result. Nth derivative of standard function. So let us derive the nth derivative of e power mx. Proof. Let y is equal to e power mx. Differentiating with respect to x, y differentiation is y1. E power mx differentiation is e power mx into m plus x differentiation is 1. Differentiating again with respect to x, and y1 becomes y2 is equal to e power mx differentiation is e power mx into m into m is m square e power mx. Similarly, third derivative y3 is equal to m cube e power mx, and so on to proceed to differentiating. It gives nth derivative yn is equal to d power n of e power mx is equal to m power n e power mx. This is the nth derivative of e power mx. Related examples. Find the nth derivative of y is equal to e power 3x. Let y is equal to e power 3x, take nth derivative on both the sides. This is already in the standard form e power mx. Just you note on the m value. Here m value is 3 power n into e power 3x. Second example. Find the nth derivative of y is equal to e power minus 5x. Take nth derivative on both the sides. Same thing here, m value here minus 5. Just substitute m value in the standard formula, minus 5 power n into e power minus 5x. One more standard nth derivative of a power mx. Let y is equal to a power mx. Differentiating with respect to x, y differentiation is y1, a power mx differentiation is a power mx into log a into m, because x differentiation is 1 into m. Differentiating again with respect to x, only a power mx, it repeats the same term, and y2 is equal to m square a power mx into log a whole square. Similarly, if we differentiate again, y3 third derivative, y3 is equal to m cube a power mx into log a power 3, and so on differentiating, it gives nth derivative of a power mx is equal to m power n a power mx into log a power n. This is the nth derivative of a power mx. Related examples. Find the nth derivative of y is equal to 5 power 3x. Let y is equal to 5 power 3x. Take nth derivative on both the sides. This is in the standard form a power mx. Here a value is 5, m value is 3. m power n, 3 power n, 5 power 3x into log 5 power n. Second example, find the nth derivative of y is equal to 3 power minus 2x. Let y is equal to 3 power minus 2x. Take nth derivative on both the sides. Here a value is 3, m value is minus 2. So minus 2 power n, 3 power minus 2x into log 3 power n. One more nth derivative of x power n, where n is a positive integer. Let y is equal to x power n. Differentiating with respect to x, y differentiation is y1, x power m differentiation is m into x to the power of m minus 1. Again y1 differentiation is y2, x power m minus 1 differentiation is m minus 1 into x to the power of m minus 2. And so on proceeding like that, it gives yn is equal to m into m minus 1 into m minus 2, so on m minus n plus 1 into x to the power of m minus n. To reduce it to standard form, we are multiplying and dividing by m minus n into m minus n minus 1 and so on to 1. After that, numerator reduces to m factorial, denominator reduces to m minus n factorial into x to the power of m minus 1. This is the nth derivative formula for x to the power of m for n less than or equal to m. Note, if n is equal to n, if n is equal to m in the above same nth derivative, then yn reduces to n factorial. If n less than m greater than n greater than m, then yn becomes 0. One more nth derivative formula for ax plus b power m, where m is a positive integer. Let y is equal to ax plus b power m. Differentiating with respect to x, y becomes y1, ax plus b power m differentiation m into ax plus b power m minus 1, within that b0, x differentiation is 1 into a. Similarly, differentiating again, y1 becomes y2, then ax plus b power m minus 1 differentiation m minus 1 into ax plus b power m minus 2 into a square. Similarly, to proceed like that, it gives the nth derivative yn is equal to m into m minus 1, so on m minus n plus 1 into ax plus b power m minus n a power n. Again, to reduce it to standard form, we are multiplying and dividing by m minus n minus 1, so on to 1. Then numerator reduces to m factorial, denominator reduces to m minus n factorial into ax plus b power m minus n a power n. This is the result, nth derivative result for ax plus b power m. This holds good for n less than or equal to m. If note, if n is equal to m, then above result yn reduces to n factorial into a power n. If n greater than m, then yn is equal to 0. Related examples, find nth derivative of y is equal to x to the power of 11. Take n is equal to 11. Let y is equal to x power 11, then yn is equal to d power n of x power n. Take n is equal to 11, then 11th derivative. See that if n and m are same, then yn reduces to n factorial. Here n is what here? 11 factorial. So nth derivative of the given function is 11 factorial. Find nth derivative of y is equal to x to the power of n. Take n is equal to 6. Let y is equal to x to the power of n. Then yn is equal to d power n of x power n. Take n is equal to 6. Here n value 6, m value 7. So then m factorial divided by m minus n factorial into x to the power of m minus n. You simplify, it gives 7 factorial into x. 7 factorial into 6. This is the nth derivative of y, 6th derivative. Find the nth derivative of y is equal to 4x plus 3 power m. Let y is equal to 4x plus 3 power m. Take nth derivative on both the sides. This is already in the standard form of ax plus b power m. Here it is a and b only at the substitute in the standard formula. A value 4, b value 3. See, m factorial by m minus n factorial into ax plus b power m minus n into a power n. That result is m factorial by m minus n factorial into 4x plus 3 power n m minus n into 4 power n. One more example. Find nth derivative of y is equal to 8x plus 3 power 7. Let y is equal to 8x plus 3 power n power 7. Take nth derivative on both the sides. Then yn is equal to m factorial here. M is what here? 7. N is not mentioned particularly. Nth derivative n 7 minus n factorial into 8x plus 3 power 7 minus n into 8 power n. A value 8. If n is equal to 7, then yn is equal to 7 factorial into 8 power n. If n greater than 7, then yn becomes 0. If n less than m, then above yn exists. And these are the references we used to prepare this video. So thank you.